Let's watch that video. Let's watch it now. Last time. Let's watch that video. Let's watch it now.
Hello and welcome to my channel. In today's episode, I am planning to put armbian CLI, or command line interface, which is a Linux distribution built by Armbian and based on Ubuntu Jammy, on a microsd card. We'll be using a Linux Mint desktop command line to do this, but first we give thanks to the products or services that make these videos possible. Instant coffee crystals and mini chocolate donuts. Yum, yum. Today's hardware. In the previous video, I described the LaPotato single-board computer and the components needed to set up and boot the Armbian build of Linux, Ubuntu Jammy, on the LaPotato. Just to recap, here are the hardware components we'll be using in the video today. The LaPotato SBC. A wired LAN switch/router. It's a Wi-Fi router. I am using the LAN portion and disabling the radio for now. There's a wall wart that goes with it. 2 Ethernet cables to go between my PC, the LAN switch, and LaPotato. A 32 GB microsd card from Amazon. This one is made in Taiwan by LaView. It has a speed class of 10. Note that the Armbian site currently warns about using SanDisk A2 class SD cards and recommends using the A1 class only if you are considering their products. I just get class 10. A USB to SD card adapter so I can mangle the content of the SD card on my desktop. A spare phone charger and micro USB cable to power LaPotato. It's rated for 2 amps. A power strip so I can boot the LaPotato separately from my desktop. As far as software, here is the web page for the current supported Armbian release for LaPotato. Note that I am using the CLI, or command line interface version, which is headless. No GUI or desktop. In a previous video, I think I referred to it as client. I also downloaded the SHA-SUM file to validate the integrity of the downloaded operating system image. You might want to read the FAQ and other notes on the Armbian website before continuing. Decompressing and validating the Armbian image. Many people prefer to use GUI tools such as USB Imager or Balena Etcher to manage and write SD card images. I believe Balena Etcher is cross-platform and USB Imager is Linux only. In this video, I will be using the command line in a couple of terminals on my Linux Mint desktop. Note that the operations we will be doing are on /tmp, and that will get wiped out if you reboot. So if you do have anything you need to save before you shut down your system, put it in your home directory or somewhere else safe. In the upper terminal, I am displaying a cheat sheet visible for the commands I'll be using. Bear with me here, I have a couple of jump cuts to reduce the wait time and correct typos. And now I'm making a temp directory /temp/potato, changing into it, and copying the working files, the downloaded compressed operating system image, and the SHA-256 checksum file into place. And now I'm using the ls-lh command to generate a listing. The -lh option is long or detailed plus human readable sizes. Now I'm using the SHA-SUM-A256 on the downloaded compressed file to validate the content. As you can see, the checksums match. The armbian build is an XZ compressed binary file. If you've heard of zip or tar files, it is similar to that, but instead the content of the compressed archive file is managed with the command XZ. So here I am testing the integrity of the compressed file content with the command xz-vt armbian ... xz. The -vt arguments indicate verbose test, which tests the integrity of the compressed archive. Now that the operating system image file is verified intact, I'll uncompress for keeps while saving the original compressed image file. The command I'll use is xz-vkd armbian ... xz. The -vkd arguments indicate verbose, keep, and decompress. And here is the result, as expected. So now I have an image to write to the microsd card. Locate the SD card and write the armbian image. In this segment, I'll use the Linux command line to locate the SD card and then write the armbian image to it. Before continuing, I need to say that I'll be using the root or administrative user account and a command line tool named dd to write the image file to a file system device. Many people would not be willing to do this because if a person makes a typo, they could wipe out their system. Another option is to use a GUI tool such as Balena Etcher or USB Imager. It's safer, and if you would like to take this route, just Google it. There are many guides on the web, including on the Armbian website. Just be aware that a mistake on the command line, for example, setting the dd command's output file to /dev/sda instead of /dev/sdb, could result in a costly, hours-long session of reinstallation of the operating system and a full restoration from backups. I have a recent backup on hand, and I have my Linux Mint installation DVD nearby, so I am assuming the risk and moving forward. We'll pick up where we left off by showing the size of the files with ls-lh star. -lh invokes the long format with human readable sizes. If you look at the top of the screen, you'll see that I've plugged in the LaView SD card and SD adapter assembly into a USB port, and it has auto-mounted with the label DOS-FMT. Now I run sudo su to become the root user and run the command fdisk-l, which lists all of the currently available file systems, whether they are mounted or not. And at this point, the /dev/sda Linux system partitions scroll by, and the DOS-FMT SD card is shown as having approximately 32 gigabytes of size located at /dev/sdb. Running the mount command, I see the DOS-FMT file system is mounted from device /dev/sdb. This is a good double check, and I made a note of it off screen. The target is at /dev/sdb. Now I U-mount the /dev/sdb device since I intend to overwrite the partition, and it's not a good practice to do that while it's mounted. Now the dd tool comes into play. Again, I have to warn that many people dislike this tool and process. Please be careful with the OF equal or output file target. The target drive is /dev/sdb in my case, and the image file is armbian ... img. So here is the command. dd if equal armbian ... img of equal /dev/sdb, bs equal 1m, status equal progress. IF designates the input file, OF designates the output file, BS sets the read-write buffer block size, and status equal progress sends verbose information to the terminal screen. This will run for a few minutes, appearing to run very fast at first as it fills up the disk buffer, then slower as the drive tries to catch up to the disk buffer, and finally it will appear to stall as the command syncs the disk buffer to the device. Overall, it took about 3 minutes and 15 seconds to complete, and it appeared stalled for the final minute and a half or so. Now I'll run sync to clear out the disk buffers. It's just an old habit and likely unnecessary here. Next, I'll use a filtered command, mount pipe grep sd, and /dev/sdb is not in the mounted list, so it hasn't auto-mounted yet. Now I unplug the USB adapter and SD card assembly and plug it back in, and up pops an auto-mount message at the top of the screen, armb_root. And I run the mount pipe grep sd filtered command again, and there is /dev/sdb1, a Linux file system labeled armb_root. Now I'll umount the /dev/sdb1 partition, and that wraps things up for this segment. We have an SD card with the armbian image ready to insert into the back of the Le Potato single board computer. The next video will be bootstrapping Le Potato Part 2, bringing up the armbian build of Ubuntu Jammy on the Le Potato single board computer. As always, thanks for watching.
Giant Bobcat!